All right, so in this video, we're going to go over exponential growth versus decay. And in particular, we want to determine in which state I'm in, whether I'm in the growth state or the decay state, depending on, or simply by looking at the function. Now, in the previous video, we discussed that determining or recognizing if the value of a was positive, then we have a function that is above the x-axis with a horizontal asymptote of being y equals to 0, or the x-axis. If a is negative, then the values go below the x-axis, right, with a horizontal asymptote still, y equals 0, but all the values are below the asymptote. Okay, so then that leaves really to determine whether it is growing or decaying, right, of this value b. Right, x is our variable, right, so that's constantly changing, right? The domain is all reals. So let's kind of take a look at these values for b. Remember, b must be positive and not 1, right? 1 is not an exponential, right? It's a constant function. So let's switch over to Desmos and take a look at just a little demonstration here. So, all right, so what we have here is we have the graph of an exponential. All right, so I have it set up here, right? Our f of x equals a times bx, right? So I have these sliders set up here to kind of vary the value of a and b, right? So first let's take a look at a just so you could see if a is positive, right, what effect that does. Now notice here, if you notice here, what the value of a does, right? It makes it looks like it's just kind of making it a little slightly steeper. It changes the y-intercept, right, for sure, right? Because remember when x is 0, right, b to the 0 is 1, so it's a times 1. So that value of a will change the y-intercept, right? Now when it's negative, so now it looks like this, right? Now it still has the same general shape. It's just reflected across the axis here. All right. Okay, and that's still, it's kind of like growing in the negative direction, right? But still getting more negative, right? So now let's go back here to 1, right? And let's look at strictly for values that are positive here. Let's vary our b. Right? So here it starts off at 1 1/4, right? So notice here as I increase it. So here we have growth, right? And the higher this b gets, right? I'm kept it at 4, but we notice here that it grows faster, right? It looks like it's almost like it's vertical. It is not vertical, right? It's still growing, right? So if we go out further, right, we have larger values. It's just not captured here, right? So it's not vertical. It's still, as you know, x is increasing from 5 to 10. The values are just getting really large really quickly. Now let's take a look at, remember we always read these from left to right. So let's go back here. All right. Okay, so b is 1, again, not an exponential, but now let's take a look at here. All right, so these are increments of 1/4, but as soon as you go to the left of 1, you get this behavior. Notice it completely flipped around. One thing that is not changed, though, is that y-intercept, right? The y-intercept here is still the value of a, right? 0, comma a, right? But what has changed now is it's kind of just got flipped across the y-axis essentially, right? It's, notice how this is where it's decaying, right? If we think of the horizontal axis to be time kind of progressing, right? So it comes from being really up here from positive infinity and then decreasing, decreasing, decreasing until it has this asymptotic behavior. Right, so notice that one thing that does not change here, right, is this the fact that the horizontal asymptote is still the x-axis. Okay. All right. So let's kind of summarize here what we have here. Now, usually for our applications, right, the value of a is going to be positive. So we'll just deal with that, right? A will usually represent some kind of population or amount of some kind of substance, right? So here, a bigger than 0, right? Some kind of positive value, right? So we're in the case where the domain is, well, always real numbers, right? Regardless of whether a is positive or negative, but the range is what's different, right? The range is going to be from 0 infinity, all right? But here, what's going to depend here, if b is bigger than 1, then we are in the growth state, and specifically exponential growth. So all our graphs are going to have this same general shape, right? Where it crosses the y-axis, how steep it all goes, that really depends on the value of b, right, and the value of a as well. Right now, if b is less than 1 but greater than 0, okay, again, remember, right, b is always a positive number, so these are the only two options. Then we are in the exponential decay state. And in general, the graph of that would look like this. Okay. All right. So that is how we can determine by looking at the graph. So for example, if we look at this, so something like this, right? This is in this interval, right, between 0 and 1. So this is representing decay. Right, and again, be careful here. Like if you have, let's say something like this, right? Don't let the fraction fool you, right? Right? Don't just see a fraction and be like, oh, that's decay. This fraction is bigger than 1. So even if it's a fraction here, it is still in this interval. So this is growth, exponential growth. Okay, so that is how you can tell just by simply looking at the graph. Or excuse me, at the equation. From the graph, it should be obvious.